Right, we've arrived at the final step of the process, which is test. Now, behind me here is a flying probe test machine. Now, in my past, if I refer to flying probe tests, I would normally be thinking about an assembled circuit board, where maybe it was being probed for functional tests. But what we're looking at here is functional test of the actual printed circuit board itself. It's the first time I've seen this, so talk us through the benefits of this process, Steve.
Okay, so this is what we refer to as a bare board test. So you refer to flying probe as an assembly test. So this is a bare board test. It's essentially a continuity test for checking for opens and shorts. So if you swing around at the screen here, what you can see here is an image. And so we're checking here against the customer's raw data. So we've got a comparative image. So we've got the design files. So we're checking here all the net ends for opens and shorts, as I said there. But one of the things we do with Soluboard at the moment, because we're still a disruptor, we're still proving our material, we do a two-stage bare board test. So we test after etch, and then we test at the end.
Right.
So we're making sure here we've got no moisture ingress, we're getting rid of any high resistance, taking sure there's no high resistance shorts, and then testing again at the end to make sure there's no moisture ingress, and then causing any shorts on the board. So we have had one example last week where we had 100% pass, but typically we're still getting a few failures, John. I mean, the truth is, material's still in development, and we do see, so this process is ultra critical for us, and we get good feedback from Ghana. We go back, we analyse those faults, microsection those faults to see where we're getting those defects.
Yeah, right. So it's more than just a kind of test, it's part almost of your R&D process.
So that leads me on, actually, you spoke about colours of the solder mask. So one of the downsides of testing at the end here is if you've got faults and you've got black solder mask, you're going to find it hard to find those faults. So that's why we like to do a test at etch and then do a test after etch as well when it's got solder mask on. Yeah. So any fault finding we can do it after etching. So, and I think that's the process that they do adopt on some of their other work as well. But generally, this is a final test. When it gets here, the faults should be good. Yeah.
Okay. Well, we've seen loads of products going through here today. Loads of examples of Soluboard, all the way from on the shelf, all the way through to test. I know a lot of those are sort of confidential at the moment, but hopefully in months, years to come, can turn into case studies. And we can see those boards in real products, in real applications, and working hard.
Yeah, definitely. I mean, some of the boards that have been made here for Jiva are boards that are being used in everyday household items, particularly in the computer peripheral market. We've done a lot of work. So there's some here today. There's some boards that are going to be used in LED lights. Some boards are going to be used in mice. Some boards are going to be used in keyboards. So yeah, there's a lot of we've got a lot of product coming through here, and a nice mix. And it's been a very, very good journey here at Ghana. Thank you.
Well, we've been tracking this technology now for at least 18 months, maybe longer than that. And there are benchmarks almost every month in terms of this technology, creating a new category of printed circuit board laminate. Now moving into a host of classic applications. We hope to be tracking this technology almost indefinitely if we can, as it moves out into the market and into volume. So I'd like to thank Steve for coming along and giving us literally a gold standard introduction to all of these processes, and obviously to Ghana Osborne for allowing us to see all of these processes in operation. Hopefully this acts as both an interesting and informative video for engineers designing boards right now, looking at sustainable processes and sustainable materials to make their products better and make the world better.
I'm going to finish again for saying thank you for Ghana for the tour, but more importantly, thank you for being our partner, being a good development partner. And I want to say a special thank you to Shaky, who makes it all happen for us.